All right, let's talk about the empirical rule and demonstrating this in Excel. You may have heard of the empirical rule if you study statistics. It's something that we say about the normal distribution. So I've got three charts here explaining what the empirical rule is, and we see that 68% of values fall within one standard deviation of the mean. So I've got this nice bell curve, normal distribution. You can imagine the mean is going to be right there in the middle, and then the shaded part in the lighter shade of pink is the values that fall within that one standard deviation of the mean. So that's our first chart. I can come down here and we see that we've got 95% within two standard deviations and then 99.7 within three standard deviations of the mean. So this is the empirical rule. It is telling us exactly what percent of values fall within 1, 2, and 3 standard deviations of the mean. What we're going to do now is build these in Excel. So I'm going to go to the next worksheet here, and you'll have access to this file. I'll give you a handout so you can follow along if you wanted to. But let's go through it together right now. Okay, so I've got the data here. Actually, I should say that we're going to fill in the data, and then the charts are over here. They'll actually start to populate on their own as we get going. Okay, so what you'll see is that I've got a mean of 50, standard deviation of 10. I've got the numbers 1 through 100 filled up and down the rows here. Now what I want to do is what's called a probability density function. So I would like to find what the probability is of finding the numbers 1, 2, and 3, etc. in a normal distribution with a standard deviation of 10 and a mean of 50. Okay, so the way I'm going to do that is with this norm.dist function, okay? X is going to be X, that's our value. Then we're going to come over here, grab our mean and our standard deviation, lock those down so we can drag this down easily. When it asks if we want cumulative, we're going to say false. We do not want it to sum, the numbers from 1 through 2 or 1 through 5. We just want exactly each row at a time. So that's going to be that mass function. I'm going to hit false here. And now you see that there is a very, very small percentage chance that given a mean of 50 and standard deviation of 10, you would get a value of 1 here. Drag this down and you can see that our normal distributions start to sprout up here. How to interpret this is that if we have a number 40, we're saying that there is about a 2.4% chance that you would find a value of 40 if your distribution has a mean of 50, standard deviation of 10. If you can imagine this, we're just going over to our normal distribution here and just picking one of these values at random right here on the x-axis, and we're seeing exactly what percent of values we would expect to be that range. So if I sum all of these, I'm going to go down to the status bar here at the bottom. You'll see that our sum is very, very close to 1. So effectively, we've got nearly every possibility accounted for with this normal distribution. We are finding pretty much all those values possibilities under the curve. Of course, these are normally distributed, so that means that we're dealing with a continuous variable. So really, you could have any of these values. You could have 73.5 or 73.2 or whatever. But we have enough granularity with our normal distribution and these x values that we are pretty safe in picking up that entire area under the curve, if that makes sense. Okay, so we got our PDF here, probability density function. Now what I want to do is overlay the 1, 2, and 3 standard deviations on these charts. So the way I'm going to do this, first I want to set up our boundaries, right? So we've got 1, 2, and 3 standard deviations. What I'll do is take our mean, let's lock that in. I want to subtract that by our numbers here. I'm going to multiply that by our standard deviation. Let's go ahead and fill that over. So here are our lower bounds, right? And let's do the upper bounds and then we can take a look at this together. All right, so we're going to want 50 and then lock that in plus, again, this is going to be your 1 times your standard deviation, lock that in. All right, so we're saying that within one standard deviation of the mean of 50, with a standard deviation of 10, would be 40 and 60, 30 and 70, 20 and 80. That makes sense, right? So now what I want to do is actually find these probability values that fall in this range, okay? If you can imagine that we've got a value of 40 here, and then it goes up to 60. So what I want to know is which of these probabilities fall in that range. And we're going to overlay, these are area charts. I'm going to overlay that area on top of this existing area. So let's take a look at how that's going to work. We're actually going to use some conditional logic here to do this. So I'm going to start with an if here, if and, because we want to make sure that this probability value in column B, that the match in column A is greater than the lower bound and less than the upper bound. So I'm going to do if and, let's do A8. I'm going to do a mixed reference there. We should really do a greater than or equal than, because a value of 40 technically counts within that range. So let's do a greater than or equal than, or equal to, I should say. Let's lock that in. If it's also, so let's do A8, less than or equal to, we want to check if that hits C6, so that's the upper bound. All right. If it's between those values, right, if it's greater than the lower and less than the upper, then we want the density function there. Otherwise, we want a 0. So basically, if you imagine our area curve, if there's a 0, we're not going to change this area. If there's not a 0, if it's this column B, it's going to overlay that range. So let's go ahead and drag this down, and you can see exactly, here's one standard deviation from the mean. 68% of values fall within that. So that kind of looks about right. We've got about 2/3 of the values here, it looks like, 68%. We're just eyeballing this, but again, this is the empirical rule. We know this just from doing exercises like this, how the empirical rule kind of shakes out. So I'm going to copy and paste this. And now you'll see that we're over to 2 standard deviations. Let's scroll down and see how this data is working out. You can kind of see that, 40 to 60, that range has been filled out. Now we've got 30 to 70 is filled out. And we can see in this case that, 95% of the values, this is almost all of it, right? There's just really these tiny little areas on the tails that aren't filled in. All right, and then last but not least, let's go ahead and just fill this over to 3 standard deviations. Now you can see that the range from 20 to 80 is filled out. And if I go in here, it effectively looks like everything's been turned into this other shade of red. That's 99.7% of values. So yes, there are definitely some values in the tails lurking somewhere, but it's really hard to see them. And it would be hard to see if we were looking for that data, not just visually, if we were really trying to find one of those numbers. You've got a less than 0.5% chance of finding a value outside of 3 standard deviations of the mean. Okay, so this is the empirical rule. I've got a finished version for you if you want to compare that out as well. I hope that you learned something here, and again, we were able to reproduce the charts over here. So when you hear empirical rule, think about the probability density function, knowing that every value is assigned a probability of meeting that value given our mean and standard deviation. And then 1 standard deviation, 2 standard deviation, 3 standard deviation has, 68%, 95%, and 99.7% of values within that range. So thank you for watching. I'll link to this so you can follow along. I've also got a handout if you wanted to print that out and then kind of go through the step by step. All right. Thanks for watching this video. This is part of my learning library for data analytics. So if you got something out of this lesson, then please check that out and subscribe. Take care. Bye.